Properties of the definite integral. There are many properties of definite integrals. The ones that we are going to look at in this section in terms of area are the ones below. So what does this actually say? Well, if we're thinking in terms of area, let's suppose we've got some curve here, y equals f of x. And this is A, this is B, and this is C. The integral from A to B would be this area here. The area from B to C would be this area here. So what this is saying is that if we add those areas, then what we get is the total area from A to C. So it's very straightforward. You just add two areas and get the sum of those areas. Now, let's look at the next bit. So what is k times f of x? Well, once again, if we've got our f of x graph here, then we know that kf of x is a vertical dilation of that graph. So kf of x might look something like this. So this integral would be the area shown here. What this is saying is that that is k times the area under the f of x curve. So once again, that makes sense. Now, what about the next one? So what we're saying here is that we have two functions. Say we've got f of x, and we've got another function, say g of x. And what we're talking about here is the sum of those functions, which might look something like this. What we have here is the area between A and B of f of x plus g of x. What this side is saying is that is equal to the area under g of x added to the area under f of x, which once again should make sense. Now the last one is actually this one combined with this one. So we have a vertical dilation of f added to a vertical dilation of g. So at the end of the day, we're just adding two functions together like this, is equal to the sum of those individual functions, which again is just this. And then if I think about this one, those constants can be slid outside the integral. Anyway, we're going to look at each of these with an example.